Hello, I'm Professor John Kelly, and this is the Weber Auto YouTube channel. It's been quite a while since I've shot videos on a regular basis, and I'm going to start doing that again. And to begin with, we are starting with a series of videos on the low voltage charging systems of hybrid and electric vehicles. And in this video, we are going to start with the world's best-selling electric vehicles, Tesla vehicles, and see how they function and what you can view inside your car in the service mode. The first part involved in the low voltage charging system is actually the high voltage battery. You can see right here we have a high voltage battery from a Tesla Model 3. The one from the Model Y looks very similar. This particular one is from a 2019 Tesla Model 3 standard range vehicle. This raised up part here in the rear has been called the penthouse in some circles, and in Tesla service information it's officially called the ancillary bay. But you can see this aluminum cover right here on the black metal housing of the battery. That aluminum cover covers some of the parts involved in the low voltage charging system. And you can see over here on the passenger side there's a stud right here that's our positive output. There's a stud over here that's our negative output for the low voltage charging system. So we have a high voltage battery and a low voltage charging system. We are going to look inside. We'll take this cover off of the ancillary bay and look inside to see the additional parts involved in the low voltage charging system. But let's see where this ancillary bay is located on the Tesla Model 3 and the Tesla Model Y. So if we come over here to our 2018 Tesla Model 3 performance vehicle, you can see that same aluminum cover right here in the back seat area. We have an orange electrical connector right here. That's the connector for the plug-in charge cord. So when you plug your charge cable into the side of the vehicle right back here, all of that current comes in on that electrical connector right there. We have the aluminum ancillary bay cover. There's an orange cover right there that is used as part of the live dead live check for disabling the high voltage system. And then if we go over to the passenger side of the ancillary bay, we can see here's the positive stud, there's the negative stud. The negative stud just has that ground bar that connects right to the vehicle chassis ground. The other stud here, the positive, comes to this big kind of reddish pink cable right there. And then we have one more electrical connector right here that connects to a great big computer inside of there called the high voltage controller, the HVC, which is basically your battery computer. So this is the location on the Model 3. Now let's go over to our 2022 Tesla Model Y performance. Okay, so as you can see, we have the positive output stud, the negative output stud. On the negative output stud, now we have a braided ground strap right here that connects to the stud and connects to vehicle chassis. Our positive output, which is 15.5 volts on this 16 volt system, is still this same reddish pink cable right there. And then I also wanted to point out while we are here, in the wiring going to the high voltage controller back here, there's a wire labeled standby power supply. And standby power supply I want you to think of as a trickle charger for the 16 volt battery that's used in all of these newer late 2021 and above Teslas with the 16 volt battery. On this Model Y, it supports a higher charge rate, and as you can see, we have a different electrical connection right here at the ancillary bay on the driver's side. So these are not all the same. There are several variations of these depending on the year, make, and model of the vehicle, but they all have basically the same internal parts. So let's go to the one on the stand over here and take a look inside of it. Okay, now that we've seen the location of this aluminum ancillary bay cover in the cars, I'm going to remove it so we can see the parts of the low voltage charging system that are underneath this. This cover has perimeter bolts going around the outside of it. It has 3, 4, or 5 additional bolts, depending on which ancillary bay cover you have, that you have to remove from the high voltage controller before we can take this off. Now, just a word of warning, a word of safety here. Don't ever take this off unless you've been properly trained on how to disable the high voltage system on these vehicles and have disabled it as far as you can go up to this point. But once you get this cover off, there's high voltage inside of here that you cannot disable. So I've got my high voltage personal protective gloves on here, our class 0 gloves, and I'm going to remove this cover now. Okay, it looks like there's a lot of parts inside of this ancillary bay, but there's really not as many as it looks. There is the high voltage controller, which is the battery computer right here, and it is on a hinge, and I can lift it up, and this part right underneath it is the power conversion system, the PCS. So the power conversion system has the input from the charge cord when you plug it into the wall, an AC level 1 or AC level 2 charge cord, and then plug it into your car. AC voltage comes in on these 2 wires. It converts it to DC at the appropriate voltage, and then charges the high voltage battery through this orange connector here on the other side. But we also have on this side of the power conversion system under the cover the DC to DC converter. And the DC to DC converter converts high voltage that it can obtain on this orange connector over here and steps it down to a low voltage where it applies it and sends it to the low voltage system on the car on these 2 studs over here. So we have our high voltage controller, the computer for the battery. We have our power conversion system. Under this cover right over here is high voltage battery negative. And if I take that cover off of there, we've got the high voltage battery negative stud sticking up off of one of the battery modules right there. And that is live right there, whatever the battery voltage happens to be charged to. Over here we have high voltage battery positive. So if I take that off, we've got the nut and the stud for the high voltage battery overall positive. So between these 2 points would be upwards of 400 volts if we had a fully charged DC battery here, the high voltage battery. Now, these 2 high voltage terminals connect to contactors. So we have a high voltage positive contactor and a negative contactor. And we haven't talked about contactors yet in my training videos, but these contactors are normally open, which means there's no connection from the high voltage terminal to the other side of each contactor. So we have high voltage here, positive, but we do not have it over here. When this contactor turns on, it connects this post to this post, which then applies positive high voltage to the rest of everything underneath the cover here. Over here, our negative terminal is connected to the contactor, which is normally open and off. So there is no negative right here. And that means that if I were to touch a voltmeter between this point and this point over here, it would be 0 volts. If I put it between these 2 points, it would be upwards of 400 volts. So right now, all of the high voltage components that you see in here, the power conversion system, we have 3 high voltage fuses, one that protects the circuit here for the power conversion system, one for the electric air conditioning compressor, and then on older Tesla Model 3s, we have a fuse here for the PTC cabin heater, the positive temperature coefficient cabin heater. And on later Model 3s and Model Ys and Model S and X, they use a heat pump. So this fuse will not be here on vehicles made approximately November of 2021 and above. We have a pyro-disconnect fuse right here. We have a current sensor shunt. And then we have 2 more high voltage contactors right here for DC fast charging. The power conversion system, the PCS, is only for AC voltage, converts it from AC to DC. If it's already DC because you're at a Tesla supercharger, then it doesn't need the power conversion system to convert it because it's already there in DC. So then it applies directly to the contactors that are then closed and applied right to the battery itself to charge the battery. So really, inside of this ancillary bay, we have the positive and negative terminals connected to the positive and negative contactors that connect to the current shunt. There's a pyrotechnic disconnect, almost like a fuse, except it's not a fuse. It just open circuits the whole battery when needed, that splits the battery right down the middle when necessary. And then we have the connection to the power conversion system. We have the high voltage controller, the additional contactors for the DC fast charge, and then our output. The red wire here is our 14 volt output and ground for vehicles like our Model 3 over there that have the lead acid battery. So we have 14 volt positive on this terminal here. It's actually 13 to almost 15 volts depending on the state of charge of the battery. And then chassis ground connected right there. If it's the 16 volt battery like in our Tesla Model Y over here, then we have 15.5 volt output pretty much constantly over there, and that's the positive, and then this is the negative or the chassis ground. So that's what's inside of the ancillary bay under the ancillary bay cover. Okay, now that we've seen the parts that are under the ancillary bay that are part of the low voltage charging system, let's build out the rest of the low voltage system for you to see. Okay, I have the ground strap and the low voltage output wire that connect to those 2 studs. So here's our ground stud right here, our ground connection for our DC to DC converter. And we've got our braided ground strap that will connect right there. Connected. And now I've got the low voltage reddish pink cable that we saw under the back seat area on both the Model S or Model Y and the Model 3. So I'll get that bolted down. Okay, this reddish pink wire that we have right here, this big heavy gauge wire, which by the way is aluminum, goes from the positive stud along the passenger side of the vehicle up towards the front kick panel on the passenger side, and it makes a connection with another wire harness that goes to up towards the front of the vehicle. So this big heavy red copper cable plugs into our output from our DC to DC converter, and then it comes up to the front of the vehicle, up under the front trunk, the front hood, and it plugs into this computer right here. This is called the front vehicle controller, or VCFRONT, as you'll see in service mode when we look at the low voltage power distribution. This VCFRONT has a protective shield on the front of it, and underneath that shield it has 6 electrical connectors. Our power feed from the DC to DC converter is going to come in on this big connector right over here. So there's this big electrical connector right here. I'm just going to plug it in directly there, close the connector position assurance clip, and this VCFRONT sits right in the front of the vehicle, right behind the low voltage battery. So here under the hood of our 2022 Tesla Model Y, we have this 16 volt battery that's disconnected because we've powered down the vehicle to take that ancillary bay cover off. But right behind it, right back there, and I've got a label on it, is that VCFRONT computer. So that electrical connection connects to that computer right there on vehicles with the 16-volt battery. If you have the 12-volt lead-acid battery, like our Model 3 does, right over here, then here is our 12-volt lead-acid battery, also disconnected as part of our high-voltage disabling procedure to remove that ancillary bay cover. And then you can see right behind that is this great big aluminum covered box labeled VCFRONT. That is your front vehicle controller for vehicles with the 12-volt lead-acid battery. So I'm sure there's different configurations for the 48-volt system in the Cybertruck also, but it will have some sort of a vehicle controller involved there. All right, so the front vehicle controller, the VCFRONT, controls everything up in the front of the vehicle under the front trunk lid or the frunk lid. And we will take a look at a pinout of what this controls a little bit later. But the main point here is that our DC to DC converter output from our PCS in the back of the battery there feeds the front vehicle controller. It does not connect to the low voltage battery. So let's see what other computers are involved and how is the low voltage battery tied into all of this. So we also have two other vehicle controllers. This one right here is called Vehicle Controller Right, or VCRIGHT. It sits in the right front kick panel just as you open the door, right where your feet go on the side of the vehicle. And if I take the cover off of this, if you look inside here, you can see a circuit board, and on this circuit board are E-fuses, electronic fuses, and each electrical connector is labeled as to what it controls. This is the VCRIGHT, so the vehicle controller for the right-hand side of the vehicle. So everything on the right-hand side of the vehicle is controlled by this computer. So this is labeled HVAC, dashboard, front seat, front door, body 1, body 2, body 3, electrical connectors. And it receives power. It has two terminals right here. We have power and ground, and it receives power from the VCFRONT, the front vehicle controller. So this is the VCRIGHT, and it would be right over here in this area of the vehicle. We have a wire coming right off of our VCFRONT that plugs into the VCRIGHT. So right there. And then it picks up its own ground, chassis ground under the front trunk just off to the side. So we've seen VCFRONT, we've seen VCRIGHT, now we have VCLEFT, of course. And VCLEFT has a very similar looking circuit board inside of it, and it controls everything on the left side of the vehicle. And you'll be able to see all three of these computers in service mode on the vehicle when you go into low power or low voltage power distribution. You'll be able to actually see the voltage input and the current input to each of these vehicle controllers. Now, this is also fed power from the VCFRONT. So I've got another harness that will connect those two, and it will also connect our low voltage battery. So let me get this positioned correctly. Okay, so I have an electrical connector that plugs into the VCFRONT right there, and then it also comes over and feeds power to the VCLEFT right there for the control of the left side of the vehicle. It picks up its own chassis ground off of its own separate wire there. Okay, it also has an output to the electric power steering assist, and there are two power steering assists. There are redundant power and grounds for the power steering assist coming off of the VCFRONT. So we'll set those there. But then also we have our battery cable going to our low voltage battery that is fed from the VCFRONT. So the VCFRONT connects to the low voltage battery. So here's the battery electrical connector right here. Here's our battery ground. It bolts to the chassis of the vehicle, and it bolts to a bolt right here on the side of the VCFRONT to establish a common ground between all of those. All right, now we'll bring in our low voltage 16 volt battery, but this could just as easily be the 12 volt or 12.6 volt lead acid battery that is also controlled by the VCFRONT here on our red Tesla Model 3, and the 16 volt one on our gray Model Y over there. So we've got the battery right here. It's going to sit right there and plug into the harness from the VCFRONT, just like that. And you will be able to see the battery voltage, the amount of current coming from the VCFRONT to the battery to keep it charged. The amount of current going to the battery is nowhere near the same as the current coming from the back of our battery there, the DC to DC converter. Those are two separate systems, and the VCFRONT is what controls the charge of the low voltage battery. Now there's one additional wire that's involved in keeping this battery charged when the car is turned off. On almost every other car, when the car is shut off, there's nothing to keep the low voltage battery charged. But on the Teslas with the 16 volt system, there is a standby power supply that feeds a maximum of 500 milliamps, or 1/2 of an amp, to this battery as needed. It has an internal BMS board, battery management system, and it watches its own internal state of charge and state of health, and relays that information to the front vehicle controller, that then over a wire that's used for something totally different when the car is on. When the car is off, that wire is not used, so Tesla is using that wire for the trickle charge from the high voltage controller in the back of the battery there. So even though the contactors of the high voltage battery are open, this high voltage controller has contactor monitoring circuits that are always connected to the high voltage battery, and it uses that to provide a power feed for the standby power supply for this, and to keep these three vehicle controllers awake all the time. These are always on. They don't draw much power, but they're always on, just in case let's say you open the driver's door. That would be an input to the VCLEFT computer that would then respond by sending messages over the communication lines to turn on the interior lights, to turn on the touch screen, and so on. So these computers have to remain on for over-the-air updates and so on. So it's really impressive that they have a built-in standby power supply to keep this battery charged. And theoretically, they told us this 16 volt battery should last forever. But there are situations where it could be run down and put into self-protection mode. And I have a totally separate video on this battery and how it goes into self-protection mode and how to recover that. All right, well, we've got the main components now of the low voltage charging system all laid out here. We've got the high voltage battery, the power conversion system under the ancillary bay that contains the DC to DC converter. That DC to DC converter feeds power right up here to the VCFRONT computer that then feeds power to the VCLEFT, the VCRIGHT, and to our low voltage battery to keep it charged. We can see your charging system in operation and see your low voltage system in operation inside the vehicle on the touchscreen. So let's take a look at that next. To view the charging system in service mode, select the car button from the bottom left of the screen, and then select software from the center menu on the screen. Next, hold your finger over the name of your car for 4 seconds, and then punch in the word service as the password, hit OK, and then enter. Now we are in service mode. Here in service mode, we have a new menu up the middle of the screen. We are going to select low voltage and then power distribution. And now we can see the low voltage system, including the power conversion system and the low voltage battery and all of the components involved inside the vehicle and their relative location. If you click your finger on each individual component shown in the vehicle, you can see the details of that component. So for example, here we are looking at the VCLEFT and its voltage and current. Now we have the VCRIGHT with its voltage and current, the low voltage battery with its individual cells and voltage, and the VCFRONT with its voltage rails and intelligent battery sensor current. Okay, all of the green circles and the green colored components on this screen indicate that there are no problems with the low voltage charging system on this car. In the bottom right corner, you can see the power conversion system output voltage and current is 33.8 amps with the car turned on, but all accessories off. Notice our low voltage lithium ion battery has an 80% state of charge at 15.5 volts, and the current is just this little tiny amount, nowhere near the output current of the power conversion system. That battery current, it's okay for it to go negative, positive, negative. Okay, we have turned on the front seat heater and the HVAC blower motor to the maximum speed, and we are getting 52.9 amps out of the PCS. Notice that the VCLEFT that controls those components is using 25.4 of the 52.9 amps that the PCS is putting out. Okay, on this screen, notice our total output is 81.2 amps, and that's because we have turned on everything we can find inside the vehicle to turn on. The seat heaters, the blower motor, the rear window defogger, we're moving the seat forward and backward, we're turning the steering wheel, and we're using a lot of current, the 81.2 amps. Notice that the low voltage battery is only receiving 2.4 amps of charge, which means it must have provided a little bit of current while turning some of these items on, but now it is recharging and almost back to normal. So if the charging system is working properly on these Tesla vehicles, the PCS should be providing a positive output voltage and a positive output current. At the same time, the low voltage lithium ion battery should be charging with a small amount of current or providing a very small amount of current with the state of charge somewhere around 80% on the lithium ion battery and around 15.5 volts. If it's a lead acid battery, then you will have an output voltage somewhere between 13 and 15 volts and just a small amount of current in or out also. The onboard diagnostic systems on these Teslas are very good at detecting problems with the low voltage battery or the power conversion system or anything else on the vehicle. And when there is a problem, you will receive a message, typically on the lower left corner of the screen like this one here, telling you something is wrong. When a problem is detected, notice the color of the component turns from green to either orange or red, indicating that some sort of a service alert has been detected and it needs to be diagnosed. Okay, this has been an overview and a demonstration of the low voltage charging system here on the Tesla Model 3 and the Model Y. But I plan on making additional videos for the low voltage charging systems on the other vehicles that I have access to here, as far as hybrid and plug-in hybrid and battery electric vehicles. So thank you for watching and have a good day.